30,000 tons of pure power.
This isn't just another train rolling down the tracks.
Before we dive in, if you enjoy powerful trains and amazing engineering, make sure to hit the like button. It really helps the channel grow.
This is 30,000 tons of moving power, a weight so massive it rivals some naval ships. And right now, it's standing completely still. So how do you move something this heavy? Today, we're about to witness one of the most powerful machines in the world come to life. 30,000 tons. Just hearing that number is hard to imagine.
Picture around 300 freight cars, each carrying nearly 100 tons of cargo. When lined up, they stretch for miles along the track. Now imagine trying to move all that weight from a complete stop. Before the train even begins to move, it has to overcome enormous resistance. And that's only on flat ground. Add even a small incline, just one of these machines is like a mobile power station. At its core is a massive 12-cylinder diesel engine, capable of producing 4,400 horsepower on its own. Now imagine 4 of these locomotives working together. That's 17,600 horsepower, all focused on one mission, moving the unimaginable. But horsepower alone isn't what makes these machines so effective. The real secret lies in something called tractive effort, the actual pulling force between the wheels and the rail. A single locomotive can generate nearly 200,000 pounds of starting pull. That's the strength that allows the locomotive to grip the rails and begin moving enormous loads. In the past, legendary steam locomotives amazed the world with their strength. Daves combine raw power with advanced technology, making them more efficient and incredibly capable. So how do 4 massive locomotives act like one perfectly coordinated machine? The answer lies in a system called distributed power, often known as DPU. From the lead locomotive, the engineer controls them all using advanced radio communication. This setup spreads the force evenly across the train, reducing stress and allowing smoother operation. Another key factor is adhesion, the grip between the wheels and the rails. Modern locomotives use powerful AC traction motors and smart computer systems to maintain control. If you're enjoying this deep dive into powerful trains, consider subscribing. We bring you incredible railway stories every week. Modern locomotives use powerful AC traction motors and smart computer systems to maintain control. If a wheel begins to slip, the system instantly adjusts power to restore grip. Sometimes, sand is automatically applied to the rails to improve traction. And now, the moment arrives. The engineer slowly increases the throttle. Deep inside each locomotive, the diesel engines rise from a low rumble to a powerful roar. Massive generators spin into action, sending electricity to motors on every axle. For a brief moment, nothing happens. Then the slack between the cars tightens, one after another, sending a chain reaction down the length of the train. And finally, the wheels begin to turn. By the way, have you ever seen a train this long in real life? Let us know in the comments. The 30,000-ton giant shudders, then slowly begins to move. At first, the motion is almost unnoticeable. But steadily, the train gathers speed. The 4 locomotives now work as a single system, perfectly synchronized, delivering power smoothly. But in reality, it's an incredible demonstration of engineering precision. It may look routine on busy railways, but in reality, it's an incredible demonstration of engineering precision. This 30,000-ton train isn't just about strength. It represents efficiency, teamwork, and some of the most advanced engineering in the modern world. It's how raw materials travel across continents and how everyday goods reach our cities. What's the most impressive machine you've ever seen? Let us know in the comments. And if you enjoyed this journey into the world of powerful machines, don't forget to like and subscribe for more incredible train stories. Thanks for watching. Stay tuned for more powerful machines that keep our world moving.